All right, let's get started. It's about 2:30. Couple things. Remember the lab's due tonight at midnight. I think pretty much. Did you get it working?
No.
Okay. Definitely start. Don't leave it until like 10 or 11 p.m. You're not gonna get it done if you do. What about you, Justin? Okay, you got it done. All right. So, and then. I know you two were in the lab, and then you said you got it done. So, all right. So make sure to get that turned in by midnight. Also, the homework assignment is due at midnight. That's the Chapter 9 problems. So the plan for today, I want to start Chapter 10. And Chapter 10 is kind of interesting. It basically just introduces a bunch of functions that you can use with characters, strings, and C strings, which we're going to talk about. We're going to talk about C strings today. I mentioned it the last time, but I want to talk about C strings more. So that's the plan for today. And then Monday, I think we're just going to be writing some code together for Chapter 10. We'll either write, there's 2 programming challenges due on Monday at midnight. We might work on one of those together in class. That's what I'm thinking right now. Say that again. There's 2 problems. There's 1 programming challenge, but it has 2 programs. So I'm thinking maybe we'll work on one of those together in class on Monday. I think a lot of you might have some finals on Tuesday, so I didn't want to come in and give a bunch of new material like the day before finals.
The program challenge all Chapter 10 stuff?
Yeah, but it's kind of... the thing with Chapter 10 is, you're going to see this as soon as we start getting into it, you almost have everything you need to do these already. There's just a few functions that you might need to look up. Like you're going to see today, Chapter 10 is really just a bunch of functions that you can use with characters, with strings, with C strings, and we're going to define what a C string is. We've already kind of been using C strings, you just didn't know it. A C string is just a character array with a null terminator at the end. But we're going to talk more about that. So that's the plan. But I think if we write one of those together in class, you'll just have the other one to do on your own, and I think that should be pretty manageable. And then I'm still planning on putting the final online. I looked it up, so the final for this class is officially scheduled for Friday. So I think what I'm going to do, I don't know if I'm going to get it online on Tuesday, but I don't know if it'll be live on Tuesday. I'm going to try and get it online by Wednesday, so then it will be available from Wednesday through Friday at midnight. So that's the plan with that. And it's going to be like the other exams. The only difference is the other exams were timed for 50 minutes. This one, the final, will be timed for 120 minutes because it's a 2-hour final. And it's going to be comprehensive. But this class, we're using stuff now that we learned in Chapter 2 and 3 and 4. So this material is pretty comprehensive anyway. I mean, we wouldn't be able to do what we're doing now without a lot of the earlier material.
My biggest concern is like the different terminology. How much of that would be in there?
What do you mean, different terminology?
Like, this is called, I don't even know, like, names, like, terms for different groups besides just the forward while or do while.
Yeah, I mean, I think that if you're worried about remembering, like, specific terms, what I would recommend doing is making a note sheet with those terms, like the ones that you think you might have trouble remembering, because the exam is open note, open book, open internet, but you're not going to have time to look up how to do everything. But I think it's okay to have a like a note sheet. And I actually think that, like, I let my other classes have note sheets, and the main reason is because I think you actually learn more putting that together than you really use it. Like, when I used to create note sheets for finals or for exams even, I always felt like just the process of going through the material and putting my notes into a shorter, I don't know, more concise summary, I feel like that helped me make connections with the material and really put everything together. So I think just the process of making a note sheet is really helpful. So that's what I would recommend doing if there's certain things that you think you have trouble remembering. It's going to be roughly double what the other two exams were. I can't remember how many questions were on those.
What is the ratio of shorter questions to longer questions?
I haven't planned that out yet either. It's the plan is to make it roughly double what the other two exams were, and I think the other two exams had probably 2/3 shorter and maybe 1/3 longer. I based the length on, like, I create the exam and then go through it, and I figure I should be able to do it faster than you guys. So if it's taking me too long, then I know it's too long.
Also, with the longer ones, I noticed on one of the other exams they were all at the end, which made it a little bit difficult to account for the time it might take for each longer one.
Okay, I can mix those up a little bit more.
That will help me a lot.
Okay.
Also, is it going to be like the other exams where it grades all of the short answer ones?
Yeah, but I double check all of those.
Okay, because yeah, I noticed on the first two exams that I put in something, where was that? There was one, for example, that was asking for just C math.
Yeah.
But I put the entire directive.
Yeah, and so you got credit for that.
Yeah,
like,
so I'm just wondering.
Yeah. Yeah, so just answer it, and if it tells you that it's wrong, don't worry about it, because I go back and double check all of those. So I'm hand checking it too. The part of the challenge with making an online exam like that is I can either just make it multiple choice, or I can let you fill in the answer. And if I let you fill in the answer, I can't predict every single answer that's going to be put in. So I just try and put in what I think is going to be most of the responses, and then if someone answers something slightly different, I'll go back and give you credit. And I don't want to do multiple choice because I hate multiple choice exams.
My logic is that if it's fill in the blank, you're not sure if it's the correct answer, but with multiple choice, there's a 25% chance that you're getting the right answer if you're randomly guessing.
Yeah, but the thing with multiple choice is usually they have a bunch of answers that could possibly be right, and so sometimes you're picking between 3 right answers, but you have to pick the most right one. And if you're not doing, I mean, with a math test, that's a little bit different because the most right one is like the only answer. But when you're talking about something that's not math, it might be a little more subjective. And I think that multiple choice also gives more room for second guessing yourself. I think if it's just open answer, you see the question and then you're like, oh, I know the answer, and you put it in. But then with multiple choice, if you see a bunch of answers, then you start second guessing, like, well, I think it's this, but I'm not sure. I don't know. I always did worse on multiple choice exams than on open answer exams, and I think it's because I would always second guess myself when I saw the list of answers. Well, let's start talking about Chapter 10. And if you think of any other questions about the exam, I can answer those on Monday as well. Really, I'm just planning on it being a longer version of what you've already had. And you guys have all been pretty much, the averages have been pretty high on the exams. I think you guys have been doing good on them. So I don't think you need to worry too much. All right. So let's start at chapter 10. So the first thing we want to cover in chapter 10, and like I said, chapter 10 is just a bunch of different functions that we can use with characters, strings, and C strings. We've been using characters and strings a lot. C strings are going to be a new concept, but we've been using character arrays a lot, and that's basically all a C string is. So let's first start with functions that we can use with characters. So these would be functions that we can test different characters, and these are summarized in table 10-1. So 10-1 is probably a good table to bookmark in this book for reference, because you're probably not going to remember all of these, but you'll have, like, just knowing that they're available. So then if you're writing a program later to where you're like, oh, I need to know if something's a digit, or I need to know if if you have a character, I want to know if this is a digit. I want to know if this is an uppercase letter. I want to know if this is a lowercase letter. I want to know if it's punctuation. You can use one of these functions to check that. So some of these functions are is alpha. So just from the name of that, what do you think that does? Like, what do you think that's checking?
It's a character.
Well, it is a character. So let's say that we have, let's say that we've gotten some input from the user. So we have cn.get input. So we have something stored in input, and we want to find out if that input is, alphabetical. We want to find out if they entered a letter or not. So is alpha, this is going to return true if they entered a letter, and it's going to return false if not. So the way that you can use this is you can say something like if is alpha, and then you're going to send it the input, so the name of the variable, and this is going to be true if they entered a letter, and it's going to be false if they entered something else. Some other functions you can use with characters are is alpha or is alnum. Based on this name, what do you think this one does?
It's a number.
Yeah, number, but it also has this AL.
ASCII code number.
Well, AL, so I guess alphabet.
So there's a number we want to go with.
Well,
So like turn that thing the alphabetical order.
well, so like, I guess I'll tell you. So this is going to be true if you have a letter or a digit. And so what digits can you have stored in one character?
0 to 9.
Yeah, 0 to 9. So this will be true if you have a letter or if you have 0 through 9. If you have a higher number, like say you have 20, that's going to be 2 digits. So you can figure this out. So you can look up the ASCII codes for all of these in Appendix A.
That's what flipped open to see.
Yeah. All right. What about this one? So is digit. What do you think that? When do you think that will be true? Yeah. So this is going to be true for 0 through 9. There's also a few others. So is lower. This checks to see if you have a lowercase letter. Is punch. This checks to see if your character is punctuation. Is upper. Yeah, so this checks to see if you have a capital or not. And then is space. All right, so I don't think that you're going to necessarily memorize all of these, but it's good to know that they're available. So then you're like, oh, I know that you can check to see if I have a uppercase letter or not. And so then you would go look up the function for that. So just knowing that these are available is what you need. And then these are summarized on table 10-1, and you can also find a pretty long list of them online as well. All right, so this is a way that you can check to see what kind of character you have if you just get a character from the user. And just based on some of the programs we've been doing, this might be pretty useful because we've been writing quite a few programs where we are asking them for yes or no, say, and maybe we don't want to give them the option to enter a lowercase y. So then now you have a way to check and see if it's uppercase, and you can ask them to re-enter it if they enter a lowercase. The other thing you can do is there's a function that you can use with characters, and this is to change your lowercase letter to an uppercase letter or an uppercase letter to a lowercase letter. And I think that I had this in a program a while ago. So yeah. So yeah, to upper. And what this is going to do, let's say that you have, like let's say that we send, let's just say we have a couple of characters. So say character 1 is A, character 2 is B. So if we send this, say, character 1, so we send it something that's already uppercase, it's just going to return the uppercase letter, so it's not going to change anything. Although, if we send it the lowercase letter, it's going to return B, so it's going to return the uppercase letter. And I should have mentioned for all of these, we need the library C-type, so you need to include C, actually it's CC type at the top of your program. All right, and then, so this is to upper, there's also a to lower. So these can be pretty convenient, and I think based on a lot of the programming we've already been doing, you can hopefully already see a lot of things that we could have used these for. All right, now let's talk about C strings. So in C++, there's two ways that strings are stored. First of all, there's the string object, which we've been using a lot, and the other way is C strings. C strings are basically just a sequence of characters, so a character array with a null character at the end. So for instance, let's say that we have an array with hello stored in it like this. If we just put a null character at the end, and this is a 0, so this is 0, not an O. If we just put a null character at the end, that makes this character array a C string. So all a C string is a character array with a null character at the end. And we've already been using character arrays a lot, so this shouldn't be anything really all that new. It's just new terminology and a new way to think about strings. And you'll notice that if you look at the ASCII character set, the null character, the decimal value for that is 0. The decimal value for the character 0 is 48. Yeah. So don't get those confused. They're two different. They have two different ASCII codes. And what this null character does is it marks the end of a C string. So this way, your program knows the length of your string because it basically goes through the array and looks for the null character, and once it finds the null character, it knows that it is at the end of your string. And so a few other things. First of all string literals in C++ are stored as C strings. So just as a quick reminder, what are string literals? Like, what's a literal again?
Quotation mark, hello, quotation mark.
Yeah, so if we hard code something directly into the program, so like let's say we have this, that is going to be stored as a C string. And let's look at a couple things. So first, let's look at how we would actually declare a C string and what the difference between a C string is versus an array. Let's say that we have a character array, and I'm just going to call this 1. And let's say that this has 10 elements, and then we say that this is equal to U P. So this is kind of what we've been used to seeing with arrays, and I don't know if I'm going to get the 10, but this is going to store CUP in the first 3 elements, and then the other elements are uninitialized at this point. Let's say that we have, so this is a character array, but let's say now we want a C string with cup stored in it, so we can do char and then array, and I'm going to say this is 10 again, and then if we just say this is equal to cup, what this is going to do is, draw this, this is going to store cup in the first 3 elements, and then it's going to put the null character at the end of cup. So really the difference between just a character array and a C string is that a C string has the null character at the end of whatever your string is. So in this case, it's cup. We have our null character here, so we're saying this is a C string. And if we were to go back to this one and say, put a null character at the end, we can do that by just hard coding it in like that. That is going to put the null character here, and so then this is a C string. So you can create a C string by just putting a null character at the end of your array, or you can do it like this where you use the double quotes. So you have this is a string literal, and it's going to store that as a C string. So you might be kind of wondering, like, well, why do we want to use C strings? It seems like strings are quite a bit easier than thinking about, because a string kind of handles all of the mechanics for us. We don't need to worry about how it's storing it in an array. It just seems a lot easier. So the reason why we want to know about C strings is if you're using legacy code, all strings used to be C strings. So if you're using legacy code, and by legacy code that could be older code, like, I don't know, maybe code from the 90s or possibly older, it's going to have C strings in it. And so you're going to have to use C strings. Even if you're not typing C strings, you're going to have to know how to read and edit code that might have C strings in it. Also, some C++ libraries require C strings. So there might be a library you want to use or some functions you want to use. It might require a C string rather than just a string object, and so you're going to have to send it a C string to use some libraries. And then you also might want to use a C library. So in C, so we're using C++, but in C, all strings are C strings. And some companies especially might have libraries that were written in C and they still use them. And so you're going to have to use C strings with those libraries rather than a string object. So those are the main reasons we want to learn how to use C strings and at least know what it is so you can recognize it if you see it. So we've seen that we can store a C string like this. What if we want to just get a C string from the user? We can declare our array. So let's say that we have constant int size, and I'm just going to say this is equal to 10. And then let's declare an array. Let's just say that this array is going to hold a name. So we need a character array, and I'm going to say it's size. And so let's say that we want to read in some data and store it to this array. Well, we could either do, we can use a cin, but like we could just do cin name, and then whatever the user enters will be stored in that array. But the problem with that is, what if they enter a space? Like we know that, like what if they enter like two names. So what if they put something like this? We know that the CN is only going to get Bob and is going to stop reading once it gets to the space. So what we can do is we can use the get line. So CN dot get line and put in name, and then the size tells it how large the array is for those reading to. Yeah.
Can you do the same thing by doing if space plus space and then CN Tyler and then plus them together?
Yeah, so we're going to see how to combine. We're going to see how to combine arrays in a little bit later. But yeah, you could theoretically read in the first name. You could ask them for their first name, then their last name, and then you could combine those. So yeah, you could. Well, and that's with a string object. So with C strings, it's a little bit different. So yeah, with string objects, you can just add them together. So we covered that quite a while ago. With the C string, there's a function that you need to use to combine them. So we're going to talk about that a little bit later. I guess the one thing that you want to keep in mind is and why I wanted to show you this, if you're reading in, like let's say you ask the user for a name. So this name is the character array. The size is the length of the array. So knowing that we need to have a space at the end of our array for the null character, what's the longest name that could potentially be entered?
9.
Yeah.
Size minus 1.
Yeah, size minus 1. So in this case, that would be 9. Because if we have this character arrays, so 2, 3, 4, 5, 6, 7, 8, 9. So this is 10 elements. We know that we need the null character at the end. So we can't fit anything larger than 9 characters into this particular array. So if we ask the user for, say, their name or to enter some information, it's important to specify to the user how many characters they can enter. And when this reads in, so when you do the cn.get line, this is going to read in whatever the user enters, store it to the array, and it's going to automatically put the null character at the end. Do I have the wrong number?
Just by 1.
No. 2, 3, 4. Wait. 1, 2,
You have 10 boxes that are clear and then 1 box with no character.
5, 6, 7, 8, 9. Yeah, so this is... Okay, so now that we know what a C string is, now let's look at some functions that we can use with C strings. And so this will get to the combining C strings that you mentioned. And this is one thing where it just seems easier to use strings, but it's really important to know how to use C strings as well.
May not always have the option.
Yeah. Yeah, a lot of companies have old code, and you're going to get asked to edit it. So you're going to have to, if you only know how to use modern libraries, or modern features, that's going to be a problem. So it's important to learn how to do some of this older stuff, even though it's a little bit clunkier. It's still important to know how to do it. All right. So first of all, functions for C strings. So all of the functions that you use with C strings, at least the ones we're going to talk about in here, you need to include the C string library. And I'm just going to list the ones that we're going to talk about, and then we'll go through them. So there's one called string length. And actually, I'll just talk about these now. So just based on the name, what do you think string length does? Like, what do you think this function does? Yeah, it returns the length of the string. And this is, one thing to keep in mind with this is this returns the length of the string, not including the null character. So for instance, let's say that we have a C string with this should be a, so we have Bob stored in this C string, so this is going to be Bob, and then it's going to have the null character. And then what we can do is just declare an integer that's going to get the length. We can just say that length is equal to strstr, so the string length, so str length, and then we just send it the name. And what this is going to return is 3. So the value of this is 3. And the reason why is because even though, so this is something to remember, even though our C string is actually going to be 4 elements, the last element is the null character. So when you do the str length, or get the length of the string, it's only going to return 3. Yeah. So this is a really convenient way to get like the length of your string. You could also do, so you can send this say the name of your C string, or you can also just send it a string literal. So you could do str length and then just send it, say Bob. That's going to return 3. Because remember, the string literal is stored as a C string. So this is kind of convenient to also get a length of something if you're wanting to set up an array for that or do something with it. All right. Now let's look at how we would combine 2 strings. So this is done with strcat. And what this does is it copies a second string to the first string. So what I mean by that is, let's just say we have 2 strings. So we have char string 1, and I'm just going to say this is some size, and this has hello stored in it. And notice how it has the space. So that space is part of the string. And then we have char string 2 size, and then let's say this is world. And let's say we want to combine these 2 strings. We can send them both to this function, strcat, and this is going to look like this. So strcat, and we send it string 1 and string 2. So what this does is it copies the second string onto the end of the first string. And so if we were to do, like after running this, if we do say cout string 1, this is going to print out hello world because we've copied string 2 to the end of string 1. So what I mean by that is, well, let's start out. Let's say that we have, so let's say this is string 1. So we have hello, and then remember there was a space, and then we just have some question marks, so we don't know what's in these boxes yet. And this has the null character. And then let's string 2 has world stored in it, the null character. So what we've done with this strcat is we've copied this string 2, so world, into string 1. Yeah, so then once we've combined these, hopefully that's long enough. Now we have hello world, and then the null character, and then so it's just empty. So one thing that you need to keep in mind when you're using this is you need to make sure that your first string has enough space to copy the second string to it. And so it's a good idea to check if you're using this and say you're getting information from the user, so you might not know if they might enter something that's too big. You need to check to make sure it's going to fit before you do this strcat. So what you can do is say just an if statement, and you can use size of to get the size of your first string. So this would just be size of string 1. And then you want to make sure that this is greater than or equal to, and then we're just going to use the string length. So remember, we just saw str length, so we can get the length of our string. So this is going to be str length, and then string 1 plus str length string 2, and then we need a +1. Why do we need the +1? Yeah, so we need to make sure we have enough. We need to make sure we have one extra element for the null character. So then if this is true, then we can go ahead and do the strcat and combine these two strings. Or we could just do an else, and then the else is going to have a cout. Sorry, your string isn't long enough. And then you at least get that error so you know what the problem is.
So up above, when you're writing code for the strcat, how do we know that, or how do we make it that string 1 has more space than string 1 has the null?
So that's where this comes in. So you can do if, and then that size of string 1, that's going to return the length of the array. Because the string isn't taking up the entire array, right?
Yeah.
Like we have this huge array, and the string is just part of it. So the size of is going to return the size of your array, so how many elements. And then you're going to check and see if the length of string 1 plus the length of string 2 plus 1, because you need the null character. If the size of your array is greater than or equal to that, you know that you can do that copy and it's going to work. Otherwise, you're going to have to change something because one of the strings is too long. Let's look at a couple more of these functions, and I think we're going to see one function that you guys are going to be like, what? That would have made our lab one line. Just kidding, you still had to use the pointers and everything that you were doing for the lab, but what you're going to notice is a lot of the things you do early on with programming, you're just learning how to do things that there's already functions that'll do a lot of it for you. But it's important to learn how to write the code, right? Because if you learn how to write code just using existing functions, you won't know how to write your own functions. So I think it's important to know how to do this stuff.
When you make one function, it'll have like 20 other functions in it, and you'll have like 15 libraries.
Yeah. All right, so another function is string or strcpy. And what this does is if you have two strings, so let's say you have string 1 and string 2, this copies the second string to the first string. So let's say that we have a character string 1, and I'm just going to say this is 50 just to make it kind of big. And then we have hello stored to that string, and we should probably actually put a space here. And then let's say we have a second character, so this is string 2, say that's also 50. And then this has world stored to it. So if we do string copy, and then we do string 1 and string 2, this is going to copy 2 to 1. So this is going to copy 2 to 1. So after we run this, if we do a cout string 1, what's that going to print out? Well, so this is after we've run this. Yeah, so this is going to print out world because we've copied string 2 to string 1. All right, and then a couple more things. So there's also there's a couple more functions. So strncat and strncpy. So these both do the same things that strcat and strncpy do. The difference with these is you can specify the max number of characters that you can either append or copy to the first array. And so this is one way you can check your first array and see, okay, I know that I have this much room. And then you can specify that it can only copy so much. So how that would look is this strnccat. So let's say we have string 1, string 2. So this is the same as what we just did, except now we're going to have another function parameter that specifies the max number of characters that can be copied into string 1. And then strncpy, this is going to copy string 2 to string 1, and we can specify how many characters to copy. And we can either put a number there, or you can put a variable just specifying how many characters are available. So just to go through a few more of these, there's a strstr. And what this does is this looks for a C string within a C string. So for instance, let's say that we have character string. This is equal to, and let's say that this is, I'll just do the hello world again to keep it short. But let's say this is equal to hello world. And let's say that we want to find, I don't know, WO or world. Maybe we want to find a word in this. What we need to do is declare a pointer. So we can do character, and I'm just going to do a pointer is equal to, and we'll set this equal to null pointer. And then you say pointer is equal to, so you're looking for this function is going to be returning a pointer, so it's going to be returning an address. And just do strstr, and then we send it the name of the array, and we send it what we're looking for. So this is going to return the address of the first character of whatever we're looking for. So this function will take this array that we sent it, and this is actually so this function is going to take this array that we sent it. It's going to search the array for whatever it is we're looking for. In this case, it was WO. And it's going to return the address of the first character of whatever it is we're looking for. So this, when it finds this WO, it's going to return the address of W. So then you know where that is. Let's see. So one more thing before we go. There's also a string compare. And this is pretty useful because remember we can't just compare, like we can't say does one array equal another array. But with this function we can do if, and we can do string compare. And I'm just going to say string 1 and string 2, so this is kind of generic. So we're sending it two strings that we want to compare and see, are they the same? Is one, like, are they equal? And with this, we can also check and see if one string is greater than the other string. So if we want to check and see if these are equal, we're going to say, is that equal to 0? So if these two strings are equal, this function is going to return 0. So I'm just going to put 0 if equal. This is going to return a negative number if string 1 is less than string 2. In other words, if string 1 comes before string 2 in the alphabet, this will return a negative. So this is going to be if string 1 comes before string 2, and it's going to be positive if string 2 comes before string 1. All right. So sometime before Monday start, just look at this chapter. This chapter really just has a bunch of tables showing you all of these functions. And I think this is as far as we're going to go. This gets through section 10-4. We might cover a few things from section 10-5 on Monday. The rest of this chapter focuses on functions for strings. So what we've done so far are functions for characters and functions for C strings, but there's also a ton of functions for strings as well. And there's a table of them on, page, table 10-9. There's a lot of string member functions. So, like I said, you don't necessarily need to memorize all of these, but it's just good to know that they're available. So then, if you run across a case where you need one, you can just look it up. And so I think on Monday we're just going to be writing some code for one of the programming challenges. So start looking at those ahead of time too. And then just make sure you get everything turned in for tonight, and I'll see you guys on Monday.